Welcome to part 10 of Algorand for Visual Studio. In this video, we will continue with our smart contract from video 7 to add so-called ABI methods and use them in a C# client, in this case a console app. This gives a brief introduction to ABI methods too, and we will talk about ABI methods a bit more in a later video where we discuss supported data types. First, we modify our approval program to add a router. This method is defined on the smart contract base class. Note that the smart contract has various base class properties, such as the balance of the contract account. The invoke smart contract method router compiles to code that is executed in the approval program as part of app call transactions. It selects which method to call, based on application call transaction arguments. By convention, the first argument, argument 0, is called the method selector and contains an identifier for the method being called. In this example, we will add two signed integers and return the result. In order for the router to recognize it, and for the compiler to accept it, we need to decorate it with a smart contract method attribute. This has two arguments. The first says what type of app call transaction is accepted, usually the general no-op, and the second is the identifier, which should be passed into argument 0 of the app call transaction. The method arguments A and B would be passed in as arguments 1 and 2. However, as we shall see, passing arguments and encoding them correctly, and even construction of app call transactions, is not something we need to take care of. Right-click on the smart contract editor and press Generate Proxy. Save it into a folder in your project. If we take a quick look at the generated proxy, we see a method corresponding to our ABI method that deals with encoding and transaction construction. Now let's go back to our main program and try to use the proxy to call out to Algorand and add two numbers. First, instantiate the proxy, passing in the connection to your AlgoD node and the ID of the application deployed. Let's make it add a positive and negative number to get a negative result. The proxy call needs a sender account, in this case one of the sandbox accounts called creator, and the minimum fee. Now let's display the result and run the app to see what we get. After a moment, we see that the app has successfully called the Algorand network to execute our method. We can also add properties to the smart contract using the storage types described in earlier videos. In this case, we declare a call counter allocated to global storage. We can then use this in our ABI method. The proxy can then be updated just as before to make the variable available. We call our ABI method a few extra times to check the call counter is incremented. Then we get the call counter from the proxy. Let's output the call counter and run the app to see the result. Success. So in summary, we saw that a smart contract can be implemented in C# with methods and properties and used in any client by generating a proxy. The methods are decorated with special attributes to indicate how they should be called, and the properties are decorated with attributes to specify their storage allocation. Thank you for watching.